You must have used undo and redo features on many apps just like a text editor. But how are these operations actually implemented? You might have guessed it right, they use a stack. Hi, my name is Pratik and in this tutorial I'll be teaching you the fundamentals of the stack data structure. Stack is a very simple data structure and it's just like a real life stack, such as a stack of books, a stack of plates, in which the operations like insertion and removal can only happen from the top of the stack. But before we get started, make sure you check out the free masterclasses on Scalar's event page by some of the best industry leading experts. The link is in the description below. Also, subscribe the channel and don't forget to press the bell icon for more updates. Let's dive in. Let us talk about stacks today. So just like arrays and linked list, stack is a linear data structure that is used for storing data, right? And it looks very much like a real life stack, such as stack of books, a stack of plates, and so on, right? So you might have guessed the kind of behavior this stack will show. So what happens is you can insert something. If you want to put a book, that book must be inserted from the top, right? You cannot insert books directly in the middle, right? You cannot insert a book at the bottom of the stack, right? Basically, any book, let's say C++ book, it goes on the top. Then a Python book, it goes on the top of the stack, right? So this is how it's going to be. And if you want to remove some book, you will have to remove the topmost book first. Then you can remove the next topmost book. Then you can remove the next topmost book, right? Basically, it's a data structure in which insertion and deletion, they are done only at the one end, where end is called as the top of the stack, right? So if you're pushing something, this blue goes, then this blue goes, and then this yellow goes. Okay, the item which is inserted at the last, right? Last item, it is at the top of the stack, right? Now, if you want to remove something, this 3 will come out, then this 2 will come out, then this 1 will come out. So the last item is the first one to come out. So hence this behavior is also called as last in first out, right? So when you do execute these operations on your computer, undo, redo, you do, right? So when you do control Z, so the last operation has been reversed. When you do again undo, the previous operation gets reversed, right? So stack is a useful data structure if you want to implement recursion. If you want to build something like an undo redo stack, you can do that, right? And problems where this last in first out behavior is important, stack can be used there, right? Now, talking about implementations of stack, we will discuss 3 implementations. We will discuss one using fixed size array, we will see dynamic array, right, or an array list, and we'll also see using a linked list, right? So we'll go into the implementation details very soon, but before that, let us also talk about features of the stack, right? So stacks are different from arrays in a way that in arrays random access is possible. That means you can pick any ith element, but in this case, stack only limited access is possible. That means only the element which is at the top is directly available to us, right? And stacks are generally dynamic in nature. In general, we can have a fixed size stack as well, but generally we can push and pop elements, so the size of the stack can keep on changing, right? So generally we do not say it's going to have any fixed size, right? If you use an array list or a linked list, you will be able to implement a dynamic stack, right? So 3 fundamental operations that we will have with every stack is, okay, we want to push something at the top of the stack. We want to remove something, again, that happens at the top of the stack. And we want to peek, that means we want to get the element at the top. We are looking for the element, so we call it as peek, sometimes also called as a top, right? We want to seek the topmost element. That is about stack. And now let us jump into the implementation of stack. Let us talk about implementation of stack. So we will be discussing 2 implementations. One is stack that uses a fixed size array, and the second implementation would be a dynamic stack, right, which can use a array list or a linked list. Okay, so we'll discuss a fixed size array implementation and another implementation using dynamic array, which is called as array list, or we can also use linked list, right? So one of those data structures we can use to give the behavior of a stack, right? If you're using a fixed size array, right, so you have to think of a container which is getting filled and getting empty only from one end, right? That means if I say, okay, every insertion will go from here, right? So 1 2 3 4 5. If I want to insert 6, I will insert something from this end. If I want to remove something, I will also remove something from this end, right? So I can say, okay, I'll push something into the stack. So that means I'll push 6. And if I pop something, that pop will also remove 6, right? And there is one more method that we would like to implement, that okay, I want to see what element is at the top of the stack. So if you remove 6, and we call this method as peak, right? So if I want to see what element is at the top of the stack, so that element would be your 5, right? These are the three most important operations that we need to implement on a stack, right? Now clearly we can use a fixed size array to do it, right? So internally we'll say, okay, there is an array which is having fixed size, and we can add elements from this end into the array, and we can also remove elements from this end of the array. So let us see how we can implement a stack class in our code. So let us start implementing the stack using a fixed size array, right? Now if you look at this fixed size array, what are the three things you will need in this class? One is the name of the array or the container in which you are going to hold data. Another is the top variable that is going to move as you insert and delete elements. And another thing we need to know is what is the maximum capacity of the stack, right? What I will do, I will define these three attributes as data members of the class. So first thing I will have is a private array, which we call it as data. Next thing I will have as top, and another thing I will have as a constant. The default capacity can be treated as a constant. So public static final int, I can say default capacity, right? And this is equal to 10, right? Now I need to define a constructor. So I can say, okay, stack using an array, there is a constructor, and I'm not getting any default capacity, so that means my array size will be 10 in this case. So I can initialize my data array. So I can say this is equal to new int, how many integers? The default capacity, right? And what is the initial position of the top? So top is the index at which I'm going to store the element, at which I'm stored the last element. So in the beginning, I can say my top is at -1. Why? Because I have not stored anything. When you insert something, you can say, okay, 3 is there and top will come here. So top will move after you can do the insertion. So I can initialize my top variable as -1. So I can have another constructor in which I'm getting some capacity as user input. So I can say, fine, I'm getting some capacity. So in this case, I can say, okay, the array that I'm creating, it has this particular capacity, right? Or you can also put a check that if your capacity is less than 1, right? That means is it negative or 0? In that case, we can throw an exception. So I can say throw new exception, invalid stack capacity, right? So something like this we can do, and here we can say, okay, this function can throw an exception, throws exception. So this is how we will create the constructor for the stack class, right? And we are using a fixed size array. Now we have to define three functions. Okay, we have to define a push function. Okay, I want to push something into this stack, so I'm going to get data, right? Now we have to check whether my stack is full or not. Only I can push, right? So how do I check? How do I check, right? So let me do one more thing. Let me also write a function that will give me the size of the stack, right? So I'll say public int get size, right? The methods would be made public. So I want to see what is the current size of the stack, right? So can I say the current size is nothing but the value of top plus 1. So in the beginning, top is -1, and if you have not inserted anything, this output will be 0. So -1 plus 1, it will be 0. When you inserted, let's say something, so top will be at index 0. What is the size of the stack? The size of the stack is 1, right? So when you're going to push, how do you check whether the stack is full or not, right? So what you can do, just think about it. Okay, so what we can do is we can check that whatever is the current size of the stack, is it equal to the array capacity, right? So I can say if I can call the get size function, which is basically giving me top plus one, is it equal to the capacity of the stack, right? So how do I know? So I can say that capacity is nothing but array length, right? So array has a property called as length. So if these two are equal, that means my array is already full. Okay, so we are getting an error here, data dot length, because of this reason. Data is a variable here, and data is also an array here, right? I need to make it something different. I need to say this is some item that I'm pushing into the stack, and now this data means the arrays, right? If they are equal, so in that case I cannot push anything more. So I can say throw new exception, and the exception name is stack is full, right? So that is some message we can display, and we can tell this method also throws exception. All right, but if this is not the case, so what I will do, I will increment my top. Also, okay, fine, increment the top variable, and at the new position of top you are going to store that item, right? That's it. If the stack is not full, right? Function can be made as void, public void push, so we don't return anything, right? Now what is happening, that your top was here, I said push 3, so my top comes here and I put the item. I say push 4, my top comes here and I put the item. Again I push 5, top comes here, and so on, right? So eventually if your top plus 1 is this value, that means if my stack is full, okay, so get size is how many elements I've currently stored, let's say 6 7, and the capacity of the array is also 5. So if it is there, so I can say stack is full, right? So that is how we can perform the push operation on the stack, right? Now let us talk about how do we remove something from the stack, right? Now I can say I will have public int pop. Okay, I want to remove the topmost item. So again here, what you can do, you can make a check that if my stack is empty, right, then I have to throw an exception. I cannot pop from an empty stack. So if get size tells me, okay, this size is 0, there is no data in the stack, so you can say throw new exception, stack is empty, right? And here we can say this method throws exception, right? Okay, if this is not the case, I can easily remove something from the stack. I will store my answer. So answer that I want to return, it will be data of top, right? Now what I can do, I can reduce top minus minus, and I can return the answer that I have. So let's see what we are really doing. So we are saying, okay, 1 2 3 4, this is my top, right? I want to remove this, so I can simply say, okay, this top will come here, and I will copy this 4 in a variable called answer, and I will return it, right? Now you might say, okay, if I print the stack, I might see 4. That's not going to be true, because we will only print up to 1 2 3, right, up to top, right? So this data, if you want, you can make it 0, or you can keep it as it is, right? So just to make it little more clear, I can say answer of top, I'm making it 0, so that sorry, data of top, I'm going to make it 0, so that it looks good when you try to look at the entire array, right? So in general, you are not going to look at the whole array, but only the array till the top, but that's okay. So this is an optional step if you would like to do, right? Because data can be 0 also, right? So again, this is an optional thing if you want to. That is how you will remove something from the stack, right? Now we have the method to look at the topmost element, right? So sometimes this method is called as top, sometimes it is called as peak, right? If you want to look at the peak method, it's pretty easy. You just need to do the similar thing, right? So I'll say, okay, if the array is empty, then you can throw a new exception that stack is empty. Otherwise, you get the data, but you don't remove it. So that's it. You can, or you can simply return data of top. Okay, the topmost element you can return directly. So that is your peek method, right? Let us add some more methods if you want to print the stack. So I will print everything up to top, right? Public void display. So I can say for int I equal to top, I greater than equal to 0, I minus minus. So I will iterate on the items in the reverse order. So if it is like 1, 2, 3, 4, I will first say, okay, I'm going to print from top to the bottom, right? Like this. So what I will do, I'll say, okay, s out data of I. That's it, right? So that is my display method, and I can give a new line here. Okay. So any other methods if we would like to write? So maybe we want to write a method called as is empty or is full. So we can write those method as well. So I will write is empty method whether the stack is empty or not. So I can say public int public boolean is empty. So this is helpful when you want to continuously remove elements from the stack until the stack is not empty. So this method can be used, right? Now I can return if my get size is equal to 0. So this expression will evaluate to true or false. So I think this looks good. Next, we will test the functionality of this stack that we have created. Now let us write one more class so that we can test the functionality of this stack class. So I'll call it as stack demo.java, right? So in this stack demo, we will create a stack object. So main method is there. I can just stack this should be stack using an array, right? Stack using an array. I call it as stack. This is equal to new stack using an array, right? So I've created the stack object, or just call it as s. Let us push some numbers into it. So I can say s dot push 1, s dot push 2, s dot push 3. So we have to push method can throw an exception. So I can say main can also throw an exception, right? So s dot push 3, 4, 5, whatever it is, right? And then we can try to extract items from the stack. So 4, 5, 6. So I've added 6 items. Now I can say, okay, s dot display show me the stack, right? Let us run this and see what do we get, right? And at the same time, I will do one more thing. I will pop items from the stack until the stack is not empty. So while the stack is not empty, what I will do, I'll say, okay, give me the topmost element. So I can say s dot peek, print the topmost element. So s out topmost element and remove it. So I can say s dot pop, right? A pop function you can also use because it also gives you the element and remove it, right? But here we are not reading the value from the pop, we are just reading the value from the peek function. So when we are printing it, you see 6 is at the top, then 5, then 4, then 3, then 2, and then 1, right? If I do not call the display method, instead I use this while loop, what is the first element that will get removed? That will be 6, last in first out, then 5, then 4, then 3, then 2, and then 1. Let us go and run this code, and we will get a same output by removing all elements from the stack as well, right? So you can see that means our class is working perfectly fine. By default, the capacity is 10. So if I say the capacity is 5 and I try to insert 6 elements, then this code is going to throw an exception that the stack is already full and I cannot push any more elements into the stack. The next implementation of stack we will see using a dynamic array and a linked list. Let us talk about dynamic stack. Now there are two options to implement it. One is you can use an array, or one is you can use a linked list. So when I say array, we can use a dynamic array, right? So suppose you are implementing the stack using an array, and at some point your array got full. Okay, your current size is equal to capacity, right? What you can do is, using the same logic as array list, inside your push method, what you will do, you will say fine, I will create a new array of double the capacity. If this is C, I will create an array of 2x of my capacity, and I will copy the elements here, right? So that is how my push method will get changed, right? And pop will remain same. I am not going to shrink anything, so pop will remain same. Even the top method will remain same. No changes, right? Nothing changes here. Only in the push method we are going to change. So array will not overflow. Instead, it will get doubled, right? And again, this copying is a expensive operation, right? So we should make sure that this is not happening too frequently, right? So that is why initial capacity is important, right? So that is using an array list, right? Now, if you want to discuss it in the code, so you can say, okay, I have a class called stack. So either you can keep a array list object here, right? Because we have already implemented array list. It can be your implementation. It can be library based implementation as well. Whenever you get a call for push some item I, you can simply say, okay, a dot add the item I. So add function, we know it adds at the end of the array list. The code becomes even simpler, right? Or if you don't want to use the inbuilt class, right? What you can do, you can take the manual array like we did in the previous example and write the doubling logic inside the push method. So I'm hopeful that you will be able to do that part, right? Another option is you can use a linked list also, right? Now suppose we are building a stack, I got 1. So I insert that node into the linked list. So my head is updated, tail is also updated, right? Now suppose you got 2. Now the question is, where should I insert 2? Should it go at head or should it go at tail, right? One option is, okay, if I put it at tail, insert at tail, if I do it, this tail will go here, right? Okay, and suppose I got 3, then you can again insert it at tail. This tail will go here, and 3 is also inserted, right? Now the question is, if I want to remove something, if I want to pop out 3, right? How do I move this tail back, right? I cannot move it back in order one time, right? I have to traverse from the beginning. This is going to be time taking. So push is going to be order 1, but my pop is going to be order of n, which is not acceptable here, right? So hence I need a better implementation using a linked list. So let us do one more try. Suppose I got 1 and both head and tail, they got updated, right? Now if I want to insert 2, 2 will go here. I will create a new node, okay, and I will connect this node with the head. So basically I'm inserting at the head only. This head will move here, fine, right? Because that we have seen how to insert at head. Then I insert 3, I create a new node connected with the previous head, and I update this head, right? This head can come here, right? Now if I want to remove something, I can say, okay, I want to remove the topmost node. I want to pop this node, right? How do I remove it? This is now pretty easy. How? We can say, okay, fine, let me move the head from here to here, and this node now becomes eligible for garbage collection, right? That means popping is very easy. Even looking at the topmost element is very easy. So the element at the head is the element at the top. So again, if I want to remove this thing, my head will go here, and the node 2, it will become garbage collected. So using linked list also, building a stack is very easy. If you want to insert something or you want to push something, you can say, okay, I will call the add front method of the linked list, right? Or insert front, whatever it is. And if I want to pop something, I will say remove from the front. Okay, I think add first. We called it as add first. Right? I need to add at the first position and I need to remove at the first position, right? And peek is nothing but it is the get first. I want to get the first element of the linked list, right? That is how it's going to work, right? So regarding the implementation, I think it's now pretty easy given that we have implemented array list, we have implemented linked list. What you can do, you can also put that code inside your dynamic stack class as well, right? Now three options: either you write entire code, that is option number one. You define the node, you write how do we insert at front. Second option is you can use the linked list class that we have created, or the array list class we have created. So you can use your library version. Okay, if you don't want to do that, you can also use the collections array list or the collections linked list, right? Any code you can use to build your own version of dynamic stack, right? And the behavior wise, it will have same functionality, except that it will not get full unless your system memory is not full, right? So that's all for dynamic stack. Hope you understood the functionality of dynamic stack. Okay, I'll show you one more implementation of implementing dynamic stack using the stack using array class. So this class we have just written. So what I'm doing, I have created one child class called dynamic stack, and it is extending the stack using array class that we have just written. So inside this class, I have only updated the push method. So basically I have overwritten this method, right? And I have provided two constructors so that I can provide build the dynamic stack object, right? So the first constructor does not accept any capacity, so I call the constructor. So this is basically calling this method with the default capacity. So I say, okay, go and create a stack with the default capacity, right? And if I get a capacity from user, then also I call the constructor of the parent class. So super is for calling the parent class, and I give the capacity. Okay, you go and call the constructor that is here, right? So this constructor is getting called, right? And I pass in the capacity. So either I pass in the default capacity, that is 10, or I give the user defined capacity, right? So I give that. So this calls the parent constructor and initializes that array, right, of that particular size, right? The pop method, I told you it's not going to change. The peak method, it's not going to change. In the push method, if my array is full, right? So if get size is equal to data.length, right? And what I will do, I create a new array of twice the size. I copy all the elements into the new array. Okay. And I say, okay, this dot data should now point to this array, right? What happens? So data was pointing to the old array, right? Now data is pointing to the new array. So this reference is gone. That means this array will be garbage collected, right? So this is ARR. ARR is a local variable. It will be destroyed, but data is a class member, so it will not get destroyed. So using the this keyword is optional. It is for more clarity that we are talking about the data member array, not any local variable, right? So that is what we are doing here. And then after we expanded the array, we call the push method of the parent class. In the parent class, now if your array has already expanded, you will never get this condition. So this condition will never be met. Which condition? That data.length is equal. So exception will not be thrown. And what will happen? Top plus plus and data of top equal to item. So this code will actually execute if condition will not be true. So before calling the push method of parent function, I simply expand the array in case of a dynamic array. This is what I really do, and it will work. So what you need to do, you need to replace this stack with the dynamic stack. You can try it out and it will work, right? So that is another way of using inheritance and creating a dynamic stack object for you. One small change I wanted to discuss was I did a change that I made these data members which were earlier private. I made them as protected now, right? Why? Because I want to use these data members in the child class as well, right? So that is the only change I have done in the class called stack using an array, right? So with this, we come to an end for today's video. I hope you really understood the concepts of stack really well and its applications as well. Before you leave, make sure you hit the like button, share the video with your friends, hit the subscribe button, and also press the bell icon so that you never miss an update. I'll see you next time.